homework?
No.
Everything.
Huh? Everything?
This chapter is so confusing to me.
I think like everything, as the more we do it, the more it'll click, you know?
More
Yeah.
quick. All right.
I
Yeah.
agree. I was okay with that. I just had to go back and look at the formulas quite a bit, and I don't have them memorized. So.
Yeah.
All right. Do you guys want to go over homework, or do you want to just go right to the quiz?
I would say go right to the quiz.
Yeah.
Unless
Okay.
there's something specific that someone's really not.
I mean, I had a couple that I was just like, I'm not really sure what you would do with that. But it was in the let's see. I think it's in the homework. So I don't know if you guys have got to that part yet.
I haven't.
Okay, then let's just go to the quiz, because there was just a couple that I circled that were kind of open-ended questions, and they didn't have Oh, and there was one that I kind of thought was an error on their part. So I was like, wait a minute.
They have had those.
Yeah, it was on 18 in the homework. So make a note of that. But I think that they have the wrong number in the key. So, anyways, and then the one right before it was an open-ended question, which I wasn't really sure how to answer that. So, all right. Okay, so let's go to the...
Hold on, I'm going to print the homework really quick. I have to step away to go grab it. So
That's fine.
This is group 10 group meeting, right?
Yes, group meeting 10. Yeah.
I'm scared every time we do this now.
I know. Me too. I'm not doing so hot in this class.
Yeah, and I don't know, like I said last time, this is like one of my less stressful classes. Like this one sits on the back burner, so I do not give it the attention it deserves.
Yeah.
Okay. What was your question on the homework? Really quick.
Oh, yeah. It was questions 17 and 18, but it's kind of like there's a series of questions. So, but 18 I think was an error, because in their key they have the number being like 6,000 something, and the actual number that I came up with was 61.5, so I rounded it up to 62. But I don't think you rounded up to 6,000. So
Right.
I was like, what the heck?
Unless the only thing I can think of just right off the bat is perhaps you, in your margin of error, you, instead of doing 0.002, just did 0.2, that would make your number a 61 point. You know what I mean?
Yeah, I did 0.002. Are you supposed to change that for the margin of error for the calculation?
That should stay the same, right?
So I have like 1.96 times 0.008 divided by 0.002, and then I have that whole thing squared. And I came up with 61.5.
Hold on. So you had just a second. Gotta look at that formula again. So you had 1.96 times
0.008 divided by 0.002.
Oh, what is, I needed to get that number. So where did you get 0.008? Did they give that to you earlier on?
Yeah, above question 12, it says that the standard deviation. Oh, I had too many zeros. That's what it was.
0.08.
Yep, you're right. And I did it right in all the other ones. I don't know why I did it wrong in that one. Okay, so that's why it's 1,000. I was like, what the heck?
Yep.
Okay.
Okay.
All right. Well, that would have been it. Okay.
All right. Meeting. Are you guys already in?
Yeah.
Sorry. I'm in. So I completed the individual. Okay. So find the margin of error for 90% confidence interval. And the standard deviation is 50 and the sample is 25. So that just goes back to that first.
That first formula. It's 90%. So that's what is that one?
Write those down, and I forgot. I have my applet open.
I got it up too. Let me find it here.
1.645.
Yeah, that's right. So you take the 1.645 and then you multiply it by
Isn't it the 50 and u divided by the square root of 25?
Yeah. Times.
Okay. Can you guys repeat that again? So, okay, so we're on. So it's
1.645. And I'm gonna plug this into my Excel so that we can just keep using this.
Which one is the formula for this one? Is this the? We're looking for the margin of error. So this is the M equals.
M equals the P or the z-score times the standard deviation divided by the square root of the number of sample.
Oh, yeah. But what were you saying was squared?
This one isn't.
Square root.
It's a square root.
Yeah.
Okay. That's what was throwing me. Okay, so we have z-score is 1.45. Standard deviation is 50.
Oh man.
I got 16.45.
That's what I got.
Oh, well, hold on. Okay, so what were you guys getting?
16.45.
Okay, that's what I got too.
Okay.
Round to 3 decimals, so we just add another 0?
Yeah.
Okay.
Okay, which of the following statements is true? Standard deviation square is an interval estimator of the population mean. The population mean is a point estimator of mean. I think it's the X bar is a point estimator of mean, but maybe I'm wrong.
I have
Maybe
a little
it's opposite.
the chart for this.
Oh, okay.
It's in the left
I know I have that written down somewhere, but
So X. So X bar is U for the parameter population. So that's correct. The standard deviation is an interval estimator for S, not S, not that one's wrong. The next, so it's the first one.
which one is that?
No, actually, it's the last one. It's X bar is the point estimator of U or the
Mu. Yeah, that's what I thought it was, but let's see. And so X bar is the point estimator of mu, right?
Right.
Okay. Yeah, that's the one I thought it was, but I wasn't sure if it was the opposite one.
Yeah, no, it's the X-bar one first.
Okay. You got that, Phil?
Yeah.
Okay.
Hey, Gina, you're in the next question.
Yeah, you are.
Oh, yeah.
Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation is 113. She collects a simple random sample of size N64 and computes the mean as 526. Use this information for questions 5 through 8. What is the lower limit of this confidence interval? Oh, okay, so we got to figure out this whole thing. So
formula we're going to be using is going to be, or it will be the X bar. We have to do it twice, right? Oh no, we only have to do it.
Plus or minus.
We do. We're going to have to for the other one, so we'll just figure it all out. So it's X bar minus, what, 526? No, it's the Z-score, right?
Yeah.
Okay, so, which is going to be 1.96.
And then it's...
She memorized it.
I memorized it. The 95 is the easy one.
I get it. Yep.
196, and then you multiply that by the standard deviation, 113 divided by the square 64. Is that right? And then you do the plus for the other side.
That's the formula I'm using.
Okay, I'm gonna plug it in my Excel so we can just reuse it if we need to. Okay, so the X is on this one, 26 minus.
I got my answer whenever you guys are ready.
Okay. I'm just a little slow, sorry.
You too.
No, it's fine. Well, I hope I got the right answer.
Putting this in Excel, you have to make sure you have all the parentheses, so it's like it takes a little bit more. Okay, so that. Okay. Yes. Okay. I got 498.315.
Perfect.
Did you get that too?
Yep.
Okay. And then I'm just going to copy and paste that into another square and then change it to a plus. Okay. Okay. Okay, so the high end for that is going to be 553.685. So the low end is 498.315.
Okay, hold on. How are you guys? So what answers did you guys get?
Yeah, the low end is 498.315.
Okay, how did you get that?
Okay, so I took the 526, right?
Yeah.
And then you subtract, and then I put parentheses before the 1.96, and then you multiply that by another parenthesis 113 divided by square root of 64, and then I close parentheses a few times because it's Excel.
Right.
And that got me the answer of 498.315.
So I got something way different. Trying to figure out why. So I did 5. So as far as the order of operations, I did the 526 minus 1.960, right?
No, you got to times the 196.
You're going to have to buy the 1.96 times that 113 divided by square root of 64. So,
I can multiply that first.
yeah. And so you would probably go by do the square root, work that out, and then divide the 113.
And put his chest.
And so then you would take 1.960 multiplied by 14.125.
I'm so sorry, Cody.
Let me see if that.
3.685.
I love you.
Times 14. Oh, and so you're actually taking the 526 minus the 27.685.
Yep.
Okay.
I'm doing it by hand, so yeah, that's what I did.
Okay. 526 minus 27.685. And then that gave you 498.315.
Yep.
Okay, all right. So I just had my order operations off. So
And then to do it the other way, you don't have to do that whole equation again. You just plus the 27.685.
Yeah, just change the minus to a plus.
Which makes sense. Okay.
That's why I plugged it in. I like using the Excel for these because then you just have to change the then the signs, or if you increase the number of samples, you just enter that number in, as you don't have to redo the whole thing. Because I was taking way too much time on my homework going through each one, and I'm like, okay, figure this out.
Okay, so what do we do with that now? So now we have to do we still? So
yeah.
Those numbers in.
So yeah, for number 5, it's the 498.315, and then for number 6, it's 553.685.
And then do you add a comma then in between the two? When you were plugging it in, did you just put 498?
No, because 5 is asking for the lower limit of this confidence interval, and then 6 is asking for the higher. Usually, if they wanted both numbers in the same question, we would put the comma in between or something. But
okay, got it.
I think this is their way for not having to have us do that.
Okay. Okay, I'm caught up with everybody.
Okay, number 7, it says what would happen to the width of the confidence interval if Gina increased the sample size, and if you increase the sample size, then the confidence interval will decrease.
Right.
So that's what I have for number 7. Okay. And it says, what would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval? So I could go ahead and plug that into the spreadsheet just to see.
So that would be the opposite, right? Because our confidence.
I think it, yeah.
5, so it should increase.
What's the
2.576
for the 99%?
Yep.
Okay, let's see. Okay, so I get 489.614 and 562.386 if we increase the 99 to 99%. So
that would increase.
What are you looking at to double check your?
Oh, I just went back to my Excel spreadsheet and changed the 1.96 that we had for the 95% to the z-score for the 99%, or is it 99?
Yeah.
Okay.
And then let it work itself out.
Yeah, and then I changed both the plus and the minus, and it gave me the.
So what was it for the 99?
The 99 is. I'm trying to figure out how. Let's see. Okay. Sorry, my normal probability app. back here.
Is there a way? Can you screenshot your Excel sheet that you're looking at?
Yeah, I can try to share it with y'all.
Yeah.
Let's see. Okay. So this is the low end. I changed the 1.96 right in here.
Okay.
And I changed that to 2.576. Is that right? Is that the 99% Z-score or whatever?
2.576.
Okay. And then I just left everything else the same.
So it's bigger, but not by much.
And then this is the other side.
Smaller. Oh, wait. No, it's 289.6.
Yeah, it's bigger.
What was that? Oh, 562. Yeah, so it is bigger.
So it increased?
Yeah.
Yeah.
Got wider.
Okay. All right. All right, Bright Bulb Light Bulb Company is planning to study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours.
So this is the one we have to work backwards.
Yeah, it says what sample size do they need? Okay, so this is the one where you do, I'm going to write it out first before I put it into my Excel sheet. So it's the number equals, and then you take the
So it should be n equals, in parentheses,
mm-hmm.
4 times the deviation divided by the mean, or the margin of error on the bottom.
Yes.
Squared, right?
Yeah, 1.96 times the deviation, which is 400 divided by what they have, which is 50. So, and then you square that whole thing. So let me go to my Excel.
Okay. Wait, what's the Z-score again? Oh, it's for 95, which is the point...
2.576. Oh, wait, no, 1.96.
Yeah.
Sorry.
960 times...
Divided by 50.
And for the margin of error, oh, 50 hours. So 50.
And then 2. So I came up with 245.862.
Still working. Hold on.
That's okay.
Okay, I got 245.862.
Good. That's what I got. What did you get, Phil?
Yeah.
Yep. All right.
It's 246 because we got to round up.
Oh, that's right. Thank you.
Yeah.
That's right. Yeah. So always round up, even if it doesn't really. You usually don't. So.
Yeah.
246. All right.
Good thing he put that example there, else I would have rounded down.
Yeah. Oh, yeah. I forgot about that because I did this last night. So, but yes, that question we always round up. Good catch. Okay. So it says the mean salaries of 100,000 and the standard deviation 36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it's higher or lower. You set up a hypothesis test with a level significance of 0.05, and oh, so this is like from last week. You collect a random sample of N36 women's salaries and find that X bar equals 111,000. Use this information for questions 10 through 12.
The lower limit. So this goes back to the very first equation. We have to find the lower limit. So it's
Yeah, so I'm going to just go back to my other previous Excel things and enter in these numbers instead. So the mean is, the X bar is 111,000, right?
yeah. Wait a minute. Where is? Oh, yeah, there it is. Yeah, 11,000.
Okay.
100,000.
And we're trying to find 95% confidence, so it's 1.96. The standard deviation is 36,730. And the number of sampled is what? Let's see, 36. Is that right?
Yeah. So wait, why? So we just don't need that level of significance because that's not in this equation, right? Or am I doing the wrong equation? Oh, that's what we'll use to determine probably a question later on. Okay. So
I'm working out the top end too. Okay, so I have my answers when you guys are ready.
1 second. Okay. Okay.
Sorry guys, I messed something up, so it's giving me something funky.
So I had 99001. Is that?
Yep, that's what I got. 0.53, and then we round up to the nearest whole number, so it'd be 99002.
Yeah. Okay, I think that's correct then.
And then the top number,
Oh, I didn't do that one, but that should, I just have to add. So.
just add instead of subtract. And I got the 122,998.5, and so I rounded that up to 122,999.
So then I got 122, yeah, 999.
Okay. Oh, and this is the last question.
Wait. What did you guys get for number 10 and 11?
10, I got 99002 because you round up to the nearest whole number.
Okay.
And 11, what is the upper limit? It's 122,999.
122,999. Okay. I'm gonna have to rework my numbers and get those because it.
You go ahead and work them out before we finish. I mean,
Just in case we both.
yeah, because we have both been wrong. It has happened.
Okay.
And the last one's easy, all of the above.
Okay. Did you guys get 11,998.46 for the right side of that?
No.
Yeah, I did.
You
and
did?
then add or subtract that from the 11,000
Okay. Minus.
or the
Oh, I'm sorry. I was like, no, I got a different number.
11,000.
Okay. 99. Okay. So I got the lower limit. That works. 111,000 plus. 1, 2, 2. Okay, sorry. Yep, I'm good.
122,999.
Yep.
Okay. And then the last one is all of the above because it is X is normally distributed, a simple random sample is drawn from the population, and sigma is known.
Okay. I push submit.
Okay.
We got 100.
Assuming that I didn't misplace any zeros or anything.
I know. Yeah, we got 100.
Oh, good.
Yay! I need that. Especially after that exam last week. I'm like, oh, it's going to take me forever to work back from that.
Okay.
Yeah, it dropped me to a C+.
Did it? I'm like at a B+, and I'm so bummed out about that.
Yeah.
Luckily, we'll have 2 more up, you know, two
Yeah.
more exams to bring it up.
Oh, well, yeah, unless we do once I do just as dumb on that one, so that makes me sad because I felt really confident with it, but I just read some things the wrong way.
Yeah, that's what I did. I rushed myself too much and didn't give myself enough time to do it right.
Yeah. I was worrying too much about the decimals. To be like, anyways. All right, guys. I guess that's it then, unless you have some more questions or.
I'm good.
All right.
Thank you.
All right. We'll see you guys Thursday then.
See you. Bye.
Okay. Bye-bye.
Oh, sorry.
Oh, it's okay.
Yeah, sorry. I clicked out without realizing it. Anyway.
Oh, that's all right. Yeah. We'll see you on Thursday.
Okay, sounds good. Bye.
All right. Bye-bye.